Assalamualaikum and good morning, everyone. So today, my group and I will be presenting our project titled Password System, Application of Logic in Real Life for the subject MAT210 Discrete Mathematics. The purpose of this presentation is to show how logic, which we learn theoretically in class, can actually be applied in real-life systems, especially in computer security. One common example that everyone here is familiar with is the use of passwords. Passwords may look simple, but behind the system, logical reasoning is used to decide whether a password is strong or weak. This project was prepared by Group 8. Here are our group members along with their student ID numbers. My name is Nick Muhammad Ashraf bin Rosdi and my student ID is 2024245414. Each member contributed to understanding logic concepts and applying them to a real-life password system. First, let us understand what logic is. Logic is the study of reasoning. It focuses on whether a reasoning process is correct or incorrect, rather than what we personally feel or believe. In logic, we are not interested in opinions. We are only interested in whether a statement can be proven to be true or false. In our daily lives, we constantly use logic. For example, when deciding whether to trust a website, whether a password is safe, or whether certain conditions are fulfilled, logic is involved. In programming and computer systems, logic is extremely important because computers depend on logical rules to make decisions. Decisions. Next, we move to statements. Statements and logical connectives. Um, a statement is a sentence that can be either true or false, but not both at the same time. If the statement is to be true or false, a truth value is needed to value whether the statement is true or false. Logical connectives. A simple statement which will consist only a statement in which it has one subject and one predicate. It is also known as primary statement. A few primary statements can be combined to form a compound statement. The truth value of a compound statement is completely determined by the truth values of its primary statements. The primary statements are combined using connectives, logical operators, to form a compound statement. Next, logical connectives. Logical connectives are symbols used to connect statements logically. First, we have conjunction. The symbol is as shown in the diagram, and statement is and. It is indicate both statements must be true. Next, we have disjunction. The symbols is as shown in the diagram, and the statement is or. It is indicate at least one statement is true. Next, we have negation. The symbol is as shown in the diagram. The statement is not. It is indicate reverse the truth value. Next, we have conditional or implication. Symbols, arrow. Statement is if then. And lastly, we have be conditional. Okay. And lastly, we have be conditional. Symbol is as shown in the diagram. The statement is if and only if, and it is indicate both sides must have the same truth value. These symbols help us represent real-life conditions in a mathematical and logical form. Next, we have truth table. A truth table is a mathematical table used in logic which sets out the truth values of the logical expression on their functional arguments. The truth table can be used to show whether a proposition is true for all legitimate input value, logically equivalent, or logically implies. Tautology, contradiction, and contingency. There are three important classifications in logic. First one, tautology is when all of the values in the truth table are true. Next, contradiction. Contradiction is when all the truth values on the truth table are false. And for the last one, contingency, it is when the truth values in the truth table contain both true and false. Most real-life systems, including password systems, fall under contingency because the result depends on the input conditions.
Hi, my name is Muhammad Qaidi Akil bin Zaidi and my student ID is 20242778664. And today I will be explaining about content and application use based on our system. So, real-life applications often involve a significant amount of logic, such as establishing specific conditions for creating strong passwords. Programmers, in particular, must ensure that the users on their website meet these conditions to prevent unauthorized access to their accounts. This discussion will delve into the details of conditions, values, and equations in this context. So, uh, these conditions are not random, but they are based on logical rules. So, this is the condition for creating strong password based on our system. Programmers establish specific password requirements, such as mandating a minimum of 8 characters, including at least one numerical digit, and ensuring the presence of at least unique character to enhance password complexity. Additionally, they introduce the condition that all specified requirements should not be consecutive in the password. Once all these conditions are met, a robust and secure password is considered to be created. Furthermore, to facilitate detection and understanding, these conditions are assigned labels. The password itself is denoted as P. 8 characters are represented by Q. The requirement for one number is labeled as R. The need for one unique character is symbolized by S. And consecutive characters are indicated by V. The ultimate outcome is a password labeled as strong when all these conditions are satisfied. So, in this context, uh, a strong password must at least have 8 characters, at least one number, have at least one unique or special character, and lastly, the characters must not be consecutive. Okay, for the value, in logic study, there are only two input and output values to show the results, which are true and false. We use the letter T to inform us that T is for true. Meanwhile, we use the letter F to show us false. Each password condition will be evaluated as either true or false, depending on whether it is satisfied or not. For creating logical equation, we can make an equation of the first part of the condition, about at least 8 characters in the password P and one number, as Q, must be inside of the password. If there and in two statement, we will put and symbol indicate and statement. Therefore, P and Q created. This also indicates that this password is weak. Next, from the condition, we can make another part of the equation about the password. There also needs to be have at least one unique character as R, and the conditions are not next to each other as S. However, S represents password characters that need to be next to each other. This makes the condition a letter opposite of each other. In order to make this condition fulfilled, we indicate the letter S by using the symbol not S. Thus, the equation is created R and not S. This also indicates that this password is weak. Moreover, we need to put all the conditions together by using conjunction logical connectivity. Thus, we created P and Q and R and not S. Lastly, if and only if all the conditions are fulfilled, a strong password V is created. This makes an equation P and Q and R and not S by a condition of V. So, in other words, to create a strong password, the equation must be only P and Q and R and not S by conditional to V.
To make the system easier to understand, we represent each condition using symbols. For P, password has at least 8 characters. Q password has at least one number. And for R, we has password has at least one unique character. For S, password characters are consecutive. And for V is password is strong. Since we use since consecutive characters are not allowed, we negate S using not S. Since we use five word, so at the P it will become 16 true and 16 false. For Q it will be 8 true, 8 false, 8 true and 8 false. For R it will be 4 true, 4 false, 4 true, 4 false, 4 true, 4 false. For S, it will be two true, true false, two true, two false, and so on. For V, it will be true false, true false, true false, true false, and so on. Uh, for P and Q, the password is V. For N, if both conditions are true, it will become true. But if only one is false, it will be false. For not S, it will be not S. So it will be false, false, true, true, false, false, true, true. For R and not S, R and not S, it will be since same like before, and is if both conditions are true, it will be true. But if one conditions are false, it will be false. Next, P and Q and R and not S. P and Q, same like before. If both conditions are true, it will be true. But if uh, one condition is false, it will be false. Next, for P and Q and R and not S, by conditional V. Uh, so the truth table The truth table shows all possible combinations of true and false values for the conditions. By referring to the truth table, we can clearly see which combinations result in a strong password and which do not. This ensures the logic used in the system is consistent and reliable. The password is strong if and only if all conditions are met. So the final condition, so the final equation is P and Q and R and not S by conditional V. So for conclusion, uh, in conclusion, logic plays an important role in everyday systems, especially in computer security. By using logical statements, connectives, and truth tables, we can design a password system that is safe, systematic, and reliable. This shows that discrete mathematics is not only theoretical but also very practical in real life. So that's all from our group. Thank you very much. That's all from our group. Thank you, madam. My name is Wan Muhammad Shahrul bin Dajizi, student ID 2024249732.